What some folks are doing is they're trying to fit an exponential curve to this, and I like that idea. I like that idea because it does look exponential right here, doesn't it? And it even looks exponential numerically. You know, essentially 0 to 1 is infinite, but 1 to 2 is doubled, 2 to 4 is doubled, 4 to 7 is doubled-ish, 7 to 14 is doubled-ish, so it's doubling-ish. You know, each flu victim is sickening another person. So you're basically going doubling. Now if you try to run a regression, an exponential regression on this one, the problem with it is you have to pull out 0, 0, because that pisses it off. But even if you do that, I'll pull it out real quick, and then you run your exponential regression on it, and we store that to y1, let it do its thing, there it goes. So it's saying the rate is at 0.83, which is interesting, because that's too low. That rate should be close to 2 for doubling. But when I graph it, there's a little teeny tiny problem with that exponential curve. And can you see what it is? Your data is not shaped that way the whole time. It does a pretty good job of catching it here, but it misses this. And that trend, if it truly is doubling, should be much steeper. If you look at the exponential, that 0.83 that it's plotting out there, it's not steep enough. It's not rocketing up fast enough. As a matter of fact, shape isn't doing that at all. It's doing, if you will, like an S shape. It's coming in like this and then correcting and going out like this. And it can't grow forever, can it? If we lock that virus into this room, we can't just keep doubling because we're eventually going to catch all the people in the room. Once we've caught 28, we're done, right? We can't go above 28. So go ahead, Shelby.
How do you do the best fit line again?
We're not going to do this one.
Oh, okay.
I don't like this one.
Okay, never mind.
Because it's not, look, hang on, hold that thought. I'm going to put those data points back in. I'm going to put in 0 and 0 again. Okay, and I'm going to take off that curve. Back to zoom 9. Okay, there's my scatter plot. As it turns out, this one's got a funky name. I'm not exactly sure why it's called this. It's called a logistic regression. Check this one out. I'll put a quiz up next week for you guys with this one with the UN data. Go into your stat calculator and go down until you see the word logistic. L-O-G-I-S-T-I-C. There it is. Mine's on B. Logistic has an S shape to it. In other words, it's got 2 asymptotes. Remember how exponential curves have the 1 asymptote? This guy's got 2. It's got an asymptote in the beginning, and then it's got a corrective asymptote at the end. It's, if you will, a ceiling that we can't go past. Now that should make sense. We shouldn't be able to go past the ceiling, right? Because we have 28 people in the room. We shouldn't be able to sicken more than 28 people unless we go out of the room, in which case all bets are off. But if we've quarantined people, only those should get sick, and this is going to tell us how fast. Okay, you ready? Logistic, Y1. It doesn't like the zeros either, I forgot. Sorry. Like an exponential, you have to pull the zeros out. I'm sorry. I always forget that. So pull the zeros out. It's the damn algebra. Run it again. Logistic Y1 without the zeros. This is going to be ugly as sin. I don't want you to worry about the equations. Maddie's like, I hate this equation. It's also taking it a very long time.
Yeah.
Don't worry about that equation. Worry instead about how well it fits your data. Watch. Isn't that sweet? It actually tracks on the change in the data. It tracks the exponential part in the beginning, and then it tracks the tapering at the end. So if you have pure exponential growth, this is a terrible model to use. But if you've got that kind of trying to be exponential and then, that's this guy. That's this guy. Now if you look at the equation, which is awful, if you look at the actual equation, you're going to start recognizing certain numbers that make sense. The A and the B don't make a whole lot of sense. Not a whole lot of sense, but this C, this 32, should be roughly the number of people in the room. And that was. We had 28, roughly 32. So the big thing with logistic, though, is, first of all, if I put the quiz up for logistic, which I will do for you, I'll tell you, find a logistic curve. Pull the 0 points out, obviously. But the big thing is to look at how it fits the data. Now you can predict how long will it take to infect this many people, this many people, this many people. Or in what year will you have this many people on Earth, this many people on Earth, and so forth, this many people on Earth. So that's the idea. Logistic is like a baby of exponential. Exponential can grow unchecked. Double, 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 double. Logistic keeps that rate for a while and then starts getting knocked down to essentially zero growth. Carrying capacity. I think it's sometimes called natural sciences. That's it.
I got it.
You got it to work. It's not working.
No, it's working.
You're working. The big thing with this one, I always forget that the damn logistic works just like the you have to pull the 0 points out. I always forget that. I always forget that because it doesn't like the math yet. That's it. So I think what I'll do is I'll slap a couple quizzes up for you guys for next week. I'll do an exponential purely, and then I'll put a logistic one too. And I'll tell you which one to use in each one. I'll tell you which one to use in each one, so you know which commands to run. Yeah, good. Ish, good-ish. Have a good weekend.